Okay, so let's get started. So this webinar is really to talk about the Oracle Database Appliance. We've run a number of short 30-minute technology webinars, some around the Oracle Database Appliance recently, and its newer version, the X32. This webinar is primarily to talk about the value that we see our client base getting from the ODA and some success stories around that space. So we're not going to dwell too much around what the ODA is and its value prop, but we're going to have a quick recap on that. I don't want to get too hung up in technical specs and bits and bytes. This is really more around real-world value and exactly what we see people benefiting from in our client base. So just to give you some background, I know we have a number of Cintra customers here, but a number of new faces as well. So just to give you some background on Cintra, our role, and I think to wrap it up in a nutshell as it relates to this space, is within database technology, middle tier and business intelligence technology, is taking aging or problematic architectures and re-architecting them or optimizing them to give benefits. And whether that's, a full-scale data center redesign, or whether it's a simple, adding a CPU into a box, improving a storage layer, tuning SQL code, or improving business intelligence reports. We really focus in that sort of area. So in this space, in terms of ODA, it's typically our clients coming to us saying, I have this environment, it's running poorly or it needs to be refreshed. What would you recommend? And in some cases, ODA is a good fit for that, and we'll explain why. Moving on, so we're specialized and qualified, and we have a couple of new engineered systems qualifications here. As you can see from the qualifications on the right, we grew up in the database world with technologies like RAC, with performance tuning, with Golden Gate, and with Linux. And that really feeds into our success in the engineered systems world as well. And again, I'll talk about why. We won a number of awards recently over the last couple of years, but this significant one in terms of this topic is the Oracle Database Appliance Award for North America last year, which was a big deal for us. And that was really, again, around the success that we've had with implementing the ODA and some of the benefits our clients have seen. We also run our own data center that includes both the version 1 and the X32 ODAs and our own Exadata unit and ZFS storage. So we're well-versed in engineered systems and have our own playgrounds and sandboxes to test out patches and virtualization and some of the new features. So recapping really, the engineered systems area in general, we're seeing a lot more adoption for it these days, and there are a number of reasons why. I mean, certainly some technologies such as Exadata are becoming much more robust and much more applicable to more than just data warehouses as they were in the past. We're seeing, more affordability as well, and in some of the subcapacity licensing models, it makes financial sense for some organizations as well. And typically it's easier now to build a business case around some of these technologies and the time savings and the benefits that they bring to organizations. In terms of why the ODA is different and why we should consider it, a major point is the amount of savings we make in the ease of management and the ease of deployment of the ODA. When you consider commodity rack hardware, and that's where Cintra has been building our business for the last more than 10 years, it is really around the complexity in terms of how do you integrate the storage to the network, to the servers, how do you bond your network interfaces and implement jumbo frames, how do you carve up your LUNs and what stripe size should you use. Really, all of that complexity is taken off of the table. All of the touch points around, your storage guys talking to your system guys, talking to your DBAs, is really eliminated by having a pre-built cluster in a box. So as you would expect, rather than say 6 weeks to build and implement a rack cluster, you're literally now looking at days with an ODA. Similarly, with managing that environment, the overhead in managing it is far lower. In terms of what actually runs on it, though, I think the reassuring thing from most organizations' point of view is that there's nothing new here. It's 11G Enterprise Edition, it's RAC or RAC 1 node, it's ASM and grid infrastructure, and it's Oracle Linux running the unbreakable kernel. there's very little here which is new in the ODA. It's not like you're playing around with some new piece of software that Oracle's just developed that might be full of bugs. It's pretty tried and tested. The only new piece as such is the Oracle Appliance Manager, which is will be very familiar if you know Exadata and you know the sort of one command there. The Oracle Appliance Manager works along the same kind of lines. It's really responsible for these four major areas: the provisioning and the managing of storage, the patching and validation and diagnostics of the ODA as well. So really, when we look at the ODA, all of these points on this slide are taken off the table. We don't need to worry about configuring the operating system. We don't need to worry about clusterware and database software or the patch sets or the patches that they run and how those interact and may conflict with the operating system. We don't need to worry about testing our patches because Oracle's already done that. So generally, a lot of the regression testing around patches is removed purely because Oracle's already done that work up front for us. On the storage side, we don't have to worry about LUNs, multipathing, disk groups, and disk alignment. Again, all of that's covered out of the box, and in a very optimized and performant way, which I'll talk about in a second. And then, as it says at the bottom here, actually, if you have a failure of whether it's a disk or a power supply, Oracle manages all of that. So if a disk fails, you'll have a service request raised with Oracle. You'll have a new disk arrive either by the mail or a guy will turn up to replace it the next day. And typically, you just put the drive in and everything's automatically rebalanced onto it. It's very, very efficient and fault tolerant. In terms of patching, there's a really nice feature where you literally download an entire bundle of patches, which applies to everything from the ILOM and the BIOS, the firmware of the drives and the storage, all the way through to your grid infrastructure patches and your database patches and the cumulative security patches that apply on top of those. To apply them, you actually have various levels of granularity. So you can choose to update, as it says here, up to 0.3, which is really your infrastructure on your server. You can then upgrade your clusterware and your cluster software in 0.4 and your database binaries in 0.5. And you can either choose to do those in one large hit and take an outage if you have the luxury of a weekend or an overnight window, or you can break those up and do them in multiple outages and manage your downtime that way. In terms of performance, the ODA it's certainly not Exadata. It doesn't have the storage cells. It doesn't have hybrid columnar compression. But what it does have is a very, very optimized disk layer. So the way the drives are partitioned is we have the outer edge of the drives, the faster edge of the drives, allocated to data, and we have the inner edge, the slower edge of the drive, allocated to logs, which really gives us around a 50% performance improvement in terms of the IOPS that we get from those drives. So even though in the base configuration we just have 20 SAS drives, the IOPS we get from those is up around the 6,000 IOPS, which is pretty good for a direct attached storage tray. The other point here is because it's direct attached storage, we actually have fairly fat pipes to our data. And those pipes are multiplexed as well and multipathed through to the drives. So the throughput you get to the disks is pretty impressive. I think this slide speaks for itself. I think we'd all love 2,000 extra hours, and across an organization, that makes a big difference. And we've literally heard stories of DBAs that have had so much time freed up by implementing an ODA that they're able to do more with their time and actually work more on SQL tuning or capacity planning and things that are of a lot more value to an organization rather than sitting there wasting time on SRs and bugs and general pain. The other huge saving with the ODA obviously is around the CPU core management. The fact that instead of saying, hey, in 3 years we're going to need 32 cores of CPU power for our database, here we can say actually from year 1, let's start with 4 CPU cores, double it up to 8 in year 2, and really manage our CPU cores in increments going up as we require them. So it's the whole subcapacity licensing model. The important thing there is obviously that our Oracle licenses, being Oracle Enterprise Edition, are tied to the number of processes that we're running, and therefore we can really tightly manage our software costs. In terms of hardware, the ODA, the newer model of the ODA, the X32, looks very, very similar to Exadata. So the technical specs of the two database server nodes are almost identical to what you get in an Exadata unit, which is pretty cool considering the price tag on these. So what you get is two database servers. They're both 1U servers. You have, within each server, you have two 8-core CPUs. They're the latest Sandy Bridge CPUs, so they're around a 40% uplift over the old Westmere generation CPUs. In each node, you also have 256 gig of RAM, so you have half a terabyte of RAM across the cluster. And I think the other things to sort of point out here is the amount of SSD has increased dramatically in the new ODA, up to 200 gig drives. So you actually have, in the base model, you have 4 200 gig SSD drives, which are primarily used for redo logs, and 9 terabytes of usable storage for data itself. The other big difference in the new ODA is that you have the option of adding a second storage tray, and that tray literally just doubles. So we go from 9 terabytes of usable storage up to 18, and we go from 800 gig of raw SSDs up to 1.6 terabytes. So in terms of hardware specs, it's looking pretty formidable, and it really opens the door to things like consolidation strategies to mixed workload databases, and certainly makes the whole platform much more capable. The other new thing which has been added in, not just for the new ODA, but from the beginning of this year to the existing ODAs, is the ability to virtualize on the platform using Oracle VM. That functionality, I'm not going to spend too much time on it because we're fairly limited on time today, but it allows you to do things like having your DOM0, which is your hypervisor, installed on the ODA, having your ODA base, which is your clusterware and your database, running as a VM underneath that, and then having a number of these domain U's, these virtual machines, running alongside those. And those could be Oracle Business Suite, they could be WebLogic, you could run OBIEE on them. It opens up a whole wealth of options. I think the important thing to note here is that it's very simple to implement. These VMs are templates that you can download and roll on there. And obviously the whole subcapacity licensing model, which applies to the database layer, can then also apply to your WebLogic or your other options that you have installed here. So it's typically a very affordable way to build your app layer in a virtualized fashion. So moving on to what I think I hope people are going to be more interested in is Cintra's stories as to how this ODA rollout's gone and where we see the interest. So in terms of the ODA adoption, we see a number of areas where we see a very, very strong interest. And up the top here, we have a number of people who run Windows. And these people have traditionally, and due to the skill sets that they have in-house and the experience, they traditionally say, there's no way we're leaving Windows. This is where we're familiar with. Linux is a strange beast that we don't know at all. Why would we go that way? However, when they start reaching large database sizes, they start requiring high availability, that maybe Oracle fail-safe isn't the best way to go there. And the ODA, in terms of its ease of management, really appeals to that sort of mindset. So suddenly, Windows to Linux isn't such a scary thing to consider anymore. But similarly, if you're running Standard Edition and you're starting to reach those pain points, maybe you're getting to 700 or 800 gig. You can't do any online index rebuilds. You haven't got any options around parallelism. There's no options such as partitioning for your data. You really start to find yourself in a painful place. Enterprise Edition is a great way to go, but there's obviously a large price tag associated with that on your current hardware in terms of the CPU cores that you would need to license for Enterprise. The ODA with its subcapacity licensing model obviously makes a huge amount of sense if you're in that kind of situation. Similarly to the Windows example there, if people have been looking at RAC and either said it's just too complex, my systems guys have got objections to building it, maybe I haven't got the skills in-house to manage ASM and RAC, we feel that it increases the risk rather than decreases it. The ability to just roll in an engineered system where all of that is pre-configured is very, very appealing in that kind of situation. Similarly, we have clients who are on a whole bunch of different architectures. You know, they might be running HPUX and Solaris and AIX, and the ability to just simplify and consolidate onto a solid enterprise-class architecture where you're not in so much of a lonely place in terms of where the industry is. By moving to Linux, you know, it's a very well-adopted architecture. In terms of storage, you know, we've had a number of clients who are running, say, network-attached storage, you know, maybe over NFS, and they're seeing some significant pains. A quick fix, rather than, you know, trying to buy another tray of spindles to increase the IOPS available to them and solve the pain at the storage level, a much quicker and cheaper fix is typically actually to roll in an ODA with its own dedicated storage, and then start to have that storage allocated purely to the database which really needs it. And we have some specific success stories around that. And lastly, you know, the idea to have ERP in a box, whether it's WebLogic or eBusiness Suite or something of that nature, to be able to just roll that into a virtualized appliance is very, very appealing. In terms of our own experience, we've deployed more than 50 ODAs in the last year. And as you can see here, there's a real mix of different verticals where we've deployed these. It's very appealing to financial services and hedge funds in terms of the performance, and similarly with retail. Retail clients are typically running legacy versions, and the idea of being able to consolidate on 11GR2 is very appealing there. But we also have you know, logistical companies that have very high transaction rates, and online companies that require very high degrees of availability there as well. So it's a good fit across a number of the verticals that we support. So jumping into the success stories here, this was a shipping logistics company, a very large global organization who were running NetApp storage appliances over NFS. They were running it over fiber in a fairly good configuration. However, they were seeing significant problems with I/O performance. They were also running HP DL servers that were nearing capacity, and they had a mixed workload of transactional and batch, which was really competing for workload on the database servers, but also hammering the storage to the point where during peak periods, their reports would take more than 10 times as long as during quiet periods. So the I/O response times were really, really suffering. And as a result of that, you know, business reports were literally not being produced, and the business was suffering because of that. So our suggestion there was roll in some database appliances, roll in ZFS storage appliance as well. And the benefits there, on average, they saw 4 times performance improvements over their old HP with NetApp architecture. However, the real benefit was that performance was consistent. There was no tail off of that performance during peak periods. We also introduced high availability with rack and managed the workload across the cluster, having OLTP workload tied to node 1 and batch workload tied to node 2 to avoid that conflict and manage the resources better. The other huge thing we gave them with ZFS storage was the ability to clone their production database and give each of 20-plus developers their own individual copy of production every night, which takes up 0 space. So literally every morning, every developer has their own copy of production, which is very, very cool, and then takes minutes with ZFS. So this is the architecture that they run. So we have a primary Oracle database appliance running a couple of production databases, and a test and development database appliance there as well. The ZFS storage appliance, we've implemented a 2-node, 2-controller cluster effectively with high-capacity drives, because they're really only used for non-production and backup purposes at the moment. Now, the other thing that's led on to is, for the same client, we're now building a warehouse architecture, and this really is an example of Oracle software on an Oracle database and an Oracle back-end hardware. Sorry, I just had a question sent to me in the chat as to whether these slides will be available, and the answer is yes, we can make these available, as well as a recording of this session as well. So the warehouse architecture is really interesting, because it's a combination of Oracle hardware, Oracle database software, and then the Oracle middleware as well. So what we've done here is roll in the Oracle database appliance and the ZFS that we had previously, include Oracle Golden Gate for real-time replication and Oracle Data Integrator for the ELT, effectively extract, load, and transform processing. The fantastic thing here is that ZFS we can leverage for hybrid columnar compression, so we can get exadata compression with really no price tag. We can have real-time heterogeneous replication with Golden Gate, and we can have integration of ODI and Golden Gate. So this gives us this idea of a source ODA on the left, from which we're reading with Golden Gate into a staging area on the right on a warehouse ODA, and that staging area is then summarized by ODI into an analytical data store, which is a much more summarized star schema and fact table-based architecture on the right. So I think this is, just another example of where the ODA has been a really, really good fit in providing availability and also the flexibility of the performance that it gives on these different workload profiles. Another example we have here is around consolidating. This is a large national retail chain who are a high fashion retailer. They had a real mishmash of legacy systems, as many retailers do. It's very, very common to have Windows, Solaris. They had some HP stuff hanging around, 10GR2, 11GR1. And from a data center point of view, it was fairly large and complex and expensive to maintain. They also had very limited in-house DBA skills, and one poor guy there trying to manage a number of different technologies and environments. So the solution we had here was to put in 3 ODAs, one production, one DR, and one test and development. Immediately that we did that, the point of sale system that these guys use, we saw a 10 times performance improvement. And we actually tuned their SQL even more and saw between 40 and 50 times performance improvements there. So absolutely huge performance improvement. We implemented Rack 1 node for their availability and Oracle Data Guard for their redundancy. And as you would expect, just consolidating onto a single 4U ODA decreases the hardware footprint and the data center costs there. The other thing we did was integrated with their current storage infrastructure in terms of NFS mounts for external backups and sending those off-site to some cloud storage. So here's just an example of the primary and the standby ODAs as they stood. And really the way we were able to manage the license costs by sensibly activating the cores that we needed on the ODA side. I'm not going to dwell too long on this video. I think it speaks for itself. The next example we have here was around extreme time to market, and this was a global tire replacement company who were acquired by a Japanese company who said, okay, we have a standard point of sale system. We want you to push that out across your organization, and it needs to be done within weeks. Not only that, but you also need a high availability architecture, which they didn't have in any way, shape, or form. The only way we could have achieved this was via an engineered system. There was no way we could have built commodity rack hardware within a number of weeks, and a storage solution as well, and had it all up and running within a month. The ODAs and the ZFS solution that we provided to them, we had online within a week. We had all of the databases configured and ready for use within 4 weeks. So the turnaround time was tremendous, much, much faster than we could have achieved otherwise. We also gave them, again, increase in availability with Rack and redundancy with Data Guard, and also the same features that I mentioned earlier with cloning using ZFS for their test and development databases. So the value that they get from this new architecture is far beyond just getting it up and running quickly. A familiar picture, here we implemented a production database appliance, test and development, and a standby, and use the ZFS storage appliance there as the back end for backups and cloning. Last but not least, this was a big win we had this year with a virtualized environment running Oracle EBS. So this is for a national sports club chain. They were required, and again under very short timescales and pressures around the amount of hardware they were going to acquire. They were required to implement EBS under a unified platform. It had to be Linux 64-bit. They were also told that they needed to upgrade from EBS 11.5 to EBS 12.1 and migrate from 32 to 64-bit Linux. And again, really the only way we could have achieved this within their timescales was via an appliance-based strategy, purely from the time it saves in deployment. Again, as I mentioned earlier, the ability to have subcapacity licensing, both of your database and for their e-business suite, was a huge selling point for the ODA, and a single unifying platform for the entire architecture. The performance boost, again, was in the region of around 4 times over their previous architecture, and the SLA that they had for their business was improved as well, from going from single nodes into an active passive rack 1 node cluster, and implementing Oracle Data Guard there as well. So this is a very slightly different picture, but what we have here is a virtualized ODA picture where we have our ODA base, as it's called, our database cluster effectively, and then above that here we have our e-business suite applications. And as you can see here, there's a lot of granularity we were able to introduce in terms of the number of CPU cores that we activated at each of these layers for each of these different application requirements for things like Oracle Discoverer that had much lower needs than things like EBS production application servers. So moving on to talk about what Cintra can do if you choose to go down this route, or if you already have and require any assistance. We have a full design, implementation, and support services catalog that we can share with you, really going from everything from how do I design a business case to justify an ODA or an engineered system strategy. Is it even right for me? Should I be looking at something else? And we're more than open to discussing that. Should I be even using this as a building block for a cloud architecture? Should I be designing something in-house where I can actually have my own private cloud that I can rapidly provision databases on? And that's, again, a very, very good fit for the ODA. And again, it doesn't just need to be a private cloud designed on ODA. It could be designed with ODA plus Spark servers, could be ODA plus Exadata, could be ODA plus HP, Dell, or IBM commodity hardware. It really doesn't matter as long as we design it from the ground up to be a cohesive private cloud strategy. We also do lots of work around quick starting and health checking ODA and Exadata, monitoring it with grid control and a very blueprinted and customized solution that we can offer in terms of monitoring ODAs and engineered systems in general. We do a lot of work as well around how do we upgrade and get our data onto the ODA. It's a great system, but if it's just sat there with no data on it, it's not terribly valuable to us. So that covers both upgrading from prior Oracle releases and also from things like Sybase, Postgres, DB2. We have a competent migrations team and a tool set that we can leverage for that. Similarly, if we want to really minimize the downtime, we can do things like Golden Gate migrations, which can keep our ODA database in sync with whatever legacy platform we have, and really just allow us to repoint our application service at the ODA and say, okay, that's it, that's our migration done within minutes, which can be of huge value for online businesses. In terms of the performance testing, we have a set of best practices and parameters that we like that we have optimized on the ODA, as well as some other options around things like 11G result set caching, partitioning, compression, that we can leverage there as well and help you out with. And obviously all of this, if we work on these kind of projects, leads into ongoing support, which we can offer. Our support approach, many of you already know us and are already taking part in this. If you're not, just to give you the 2-second overview of it, our support approach is to give you a 4-man dedicated team, including DBAs, architects, and project managers, who you have the direct contact numbers of and can give you 24/7 fast responses. And we're talking fast responses from a senior DBA in minutes, not an hour to escalate up the chain. We also manage the whole stack, from the hardware, the operating system, the cluster, and the databases. So I think that's worth mentioning there. This slide just gives us an example of the kind of thing that we do during our support operations on ODAs and Exadata platforms in general. It really revolves around weekly health checks and proactive support, keeping things clean and tidy and keeping systems healthy, moving on to much more detailed monthly reports that contain things like capacity planning, patching and operations, performance tuning, and so on. So in terms of Cintra's role in this, our goal is to make every customer a reference customer, essentially, and we have unparalleled customer references and success rates and repeat business. So I think that's worth stressing there. In terms of the next steps, if you're interested in ODA or in any other architecture assessment from us, we can come in and help you out with that. I would suggest that you contact us to come up with a roadmap for you for where you feel that your business should be in terms of service levels, in terms of performance, and in terms of technical architecture. We can help you. We can actually look at your Oracle license installation as well, and look at where that's a good, which software is a good fit for you in terms of licensing, and where you might be able to save some money or optimize your investment there. We also have a number of blueprints for both commodity hardware and engineered systems in terms of the design and the decision points that are implemented in those. Of course, we can also offer general DBA support as well. So our contact details here, you've got info@cintra.com for general requests. You've got the contact details here of our CTO, Abdul Sheikh, who normally joins me on these technology webinars but is away today. Myself, Simon Rice. Abdul and I act as the kind of primary architects within Cintra. So feel free to fire us any technical questions, any follow-ups that you'd like there. And if you're interested in any of the services that we talked about, there's the sales email address there, or you can contact your account manager there. So I'd like to thank you very much. I'm afraid we're out of time, but if you have any questions, please do drop us an email to the addresses listed here. I'm going to leave this up on the screen for a few minutes, and we'll be happy to call you back and follow up on that. Great. Well, thank you very much, everybody, for attending, and we hope to talk to you soon. Okay, thanks.